Complex numbers.
In this session 15, we are going to see some special problems of modulus. For that, we are going to discuss about two problems. That is, the first problem is this, and the second problem is this. So we are going to discuss about these two complex numbers. First complex problem, we have three complex numbers and its modulus value are equal to one another, and they're asking to prove the above. And in the second problem also, they are giving three complex numbers but with different modulus values. Along with it, they are giving us one more clue, that is sum of the three complex numbers modulus is equal to 1, and they are asking us to prove the following thing. We are going to discuss about all these things. First, let's go to the problem number 1, the first problem. The problem is written, you have to remember, modulus of Z1 equal to modulus of Z2 equal to modulus of Z3 is equal to R. It is given by them. Right, let us try to prove this. How to prove this? Let us start with a clue. It is given that is modulus of Z1 is equal to R. This is what they have given us. Modulus of Z1 is equal to R. Separately, if you take next complex number, we can say that as modulus of Z2 is also equal to R and modulus of Z3 is also equal to R. Now let us take the first part, that is modulus of Z1 is equal to R. Right. Now, the first clue is modulus of Z1 is equal to R. We are going to square it. You may wonder why we are squaring it. Because the given clue is simply modulus values. From this modulus values, we cannot go to this big modulus value. Better to come out of this modulus. And after that, let us do some work. And if we get this complex number, after that we can take the modulus. So, first of all, we have to come out of this modulus. For that, we are squaring both the sides, because there is a formula, that is modulus of Z square is equal to Z into Z bar. That is, if you square the modulus, it will be coming out of modulus and it will become the complex number and into its conjugate. So, since it is squared, it can be written as this complex number into its conjugate. So, your answer will be Z1 into Z1 bar, that is equal to R square. From here, let us try to find Z1 bar, that is R square by Z1. As I told you, all the three complex numbers modulus are equal to one another and its magnitude or its value is R. So there is no need of doing the problem again and again. We can repeat that. Instead of keeping the number as 1, you can keep that number as 2. That is, Z1 bar can be kept as Z2 bar. Then Z1 can be kept as Z2, and we can do the same thing for the third complex number also. So we can write it in similarly way. That is, Z2 bar will be also equal to R square by Z2, and Z3 bar will be equal to R square by Z3. Now, if you add these three complex numbers, that is Z1 bar plus Z2 bar plus Z3 bar, you will be adding R square by Z1 plus R square by Z2 plus R square by Z3, and if you take R square commonly outside, it will become 1 by Z1 plus 1 by Z2 plus 1 by Z3, and if you take LCM, the numerator will take this form. So, we can come to the conclusion we have to add these three complex numbers. If we add it, surely we'll get this type of format. Let us try that. Now let us try to find Z1 bar plus Z2 bar plus Z3 bar, that is R square by Z1 plus R square by Z2 plus R square by Z3. Right. In this left side, you have Z1 bar plus Z2 bar plus Z3 bar. There is a formula. that is z1 plus z2, the whole bar is equal to z1 bar plus z2 bar. So if there is z1 bar plus z2 bar like this, then you can write that as z1 plus z2 the whole bar. The same way you can write this as z1 plus z2 plus z3 the whole bar, right? And now let's take r square commonly outside. This will be your result. If you simplify it, your answer will be like this. Just we have taken LCM here, so there is no need of worrying. You can do this by yourself. It is not a tough one, it is very easy one, so you can do this. For example, here your LCM is z1 into z2 into z3. If you consider this part, so it is a multiple of, if you take this, z2 and z3 will be a multiple part for that. So you have to multiply this 1 by z2 into z3. So z2 into z3 is here. Like that, you have to simplify this, you will get the same answer, right? Now we are going to take modulus now, right? As I told you, after getting somewhat similar to that proof, just we have to take modulus. First we came out of modulus and we have done something, and again we are going to take modulus on both sides, right? So let us take modulus on both sides. Simply modulus is taken now, right? Now if you take modulus, what will happen? This can be written as simply z1 plus z2 plus z3 inside the modulus, because there is a property modulus of z bar is equal to modulus of z. So we can use that property here, right? If we use it, we can write like this. The right hand side is as it is. The left hand side, instead of modulus of z bar, we can write modulus of z using this property, right? Now if you see the next step, if you bring this modulus of z1 plus z2 plus z3 to this right side, it will come to the division part. And if we take this z1 into z2 into z3 to the left side, it will go to the numerator, right? Now what about this modulus? Is it there, sir? Yes, it is surely there, because whole modulus is here. So if you split it, it is simply modulus of z1 plus z2 plus z3 only. So the multiplication, when it goes to this side, it becomes division, and this division part, when it goes to this left hand side, it becomes multiplication in the numerator, right? You know the property modulus of z1 into z2 can be written as modulus of z1 into modulus of z2. So let us use that property also here. So using this property, we can split this. So your answer will be modulus of z1 into modulus of z2 into modulus of z3, and same thing we are repeating in the right hand side, right? As I know very well, modulus of z1 value or modulus of z2 or modulus of z3, whatever it may be, it is given, they are all equal in magnitude, that is they are all equal in modulus, and their value is r, it is given. So we are going to apply that. So if you apply it, your answer will be r into r into r, because modulus of z1 equal to modulus of z2 equal to modulus of z3 is equal to r. So r into r into r, it becomes r cube, and we have taken r square outside the modulus. You know that if you take a constant outside of the modulus, it will not change. The constant will be coming out of the modulus, and just if it is positive, the same thing will be repeating here. If it is negative, the answer will be positive outside the modulus. That's all. Nothing is going to change in the numbers. The same number will be, same modulus number will be coming out. Just this is a number, so it will be coming out as it is. So there is no need of worrying about that, because r square is simply a positive one. So the same value will be coming out of that modulus. So this is what the answer we received. And if r square goes, that's it will become r cube by r square. Then this is the modulus. If we simplify it, r cube by r square, that will become r. So r is equal to z1 into z2 plus z2 into z3 plus z3 into z1 divided by z1 plus z2 plus z3 inside the modulus. So this is what their proof, what we have to prove, that we have proved now. So the first problem is very simple. If we remember this first problem concept, then the second problem will be very easy. Now let us see the second problem. Here they have given three complex numbers, but they are taking different modulus value. First complex number takes the modulus value as 1, and the second takes the modulus value as 2, and the third it takes the modulus value as 3. Moreover, they are giving us one more new clue, that is modulus of z1 plus z2 plus z3 is equal to 1. Then we have to prove the thing which is below to this. Right. Now again let us take the same way. Let us take any one of this modulus value. If you want to take z1, let us take z1 equal to modulus value of z1 is equal to 1, or modulus of z2 is equal to 2, whatever it may be. For example, let us take this in our work. Now modulus of z2 is equal to 2, it is given. As I told you, first we have to square both sides because we have to come out of the modulus. So modulus of z2 square is equal to 2 square. As I already told you, modulus of z square can be written as z into z bar. So using this property, we can write this modulus of z2 square as z2 into z2 bar. So z2 into z2 bar is equal to 2 square. The same way, let us try to find here also z2 bar. So z2 bar will be is equal to 2 square by z2. Similarly, we can go for z1 and z3. z1 bar will be equal to, here the modulus value is 2, so it becomes 2 square. Here the modulus value is 1, so it will become 1 square. Here the modulus value is 3, so that will become as 3 square. Right. So we got z1 bar, z2 bar, and z3 bar. Right. Let us proceed in the same way. Let us try to find z1 bar plus z2 bar plus z3 bar. So our answer will be 1 square by z1 plus 2 square by z2 plus 3 square by z3. As I told you already, we can write that z1 bar plus z2 bar plus z3 bar as z1 plus z2 plus z3 the whole bar. So our answer will be 1 by z1 plus 4 by z2 plus 9 by z3. Now let us try to simplify the right hand side. The LCM will be z1 into z2 into z3. If we simplify this, here the z1 is z2 into z3 times, so 1 into z2 into z3. Here z2 is z1 into z3 times, so this 4 into z3 into z1, and this z3 is z1 into z2 times, so this is 9 into z1 into z2. So we have simplified this. We got answer somewhat relevant like this. If you see, we are nearing our answer. Right. So this is what we received. Now let us take modulus. As in the same way, first we came out of modulus. After doing our simplifications, we are going again into the modulus. Now let us take modulus on both sides. Right, now modulus is taken. Now as I told you, modulus of z bar is nothing but modulus of z. So we can simply remove this bar. So our answer will be, using this property, we'll get the answer as modulus of z1 plus z3 is equal to the same right hand side. You know very well, it is given to us modulus of z1 plus z2 plus z3 is equal to 1. So if you substitute it, this value, if you substitute this value, it will become 1. So that is 1 is equal to same thing in the right hand side. Right. Now if we make this z1 into z2 into z3 to go that side, that is modulus of z1 into z2 into z3 will be going this side. That is modulus of z1 into z2 into z3. As I told you, that modulus can be splitted because modulus of z1 into z2 is nothing but modulus of z1 into modulus of z2. So this modulus of z1 into z2 into z3 can be written as modulus of z1 into modulus of z2 into modulus of z3 in this side. So the equation becomes like this: modulus of z1 into modulus of z2 into modulus of z3 is equal to 9 into z1 into z2 plus z2 into z3 plus 4 into z3 into z1. This is what we have to find. It automatically came here. You know the value of modulus of z1 as 1 and modulus of z2 as 2 and modulus of z3 as 3 because it is given like that. Right. So if you substitute it, right, it will be like this. So 1 into 2 into 3 is 6. So 6 is equal to modulus of 9 z1 into z2 plus z2 into z3 plus 4 into z3 into z1. So this is what we have to prove. It is proved. So if you see, the two sums are of same pattern. If you know the concept how we are doing, you can do whatever the problems of this type. You can do it very easily. Practice it and try to do in your from your exercises and from your examples. You can practice more sums. Thank you.